Now, for question 19, which asks about the empirical formula from the experiment which was carried out, the first thing we need to find out is, so in the experiment, there was a hydrocarbon, CXHY, which combined with oxygen to give carbon dioxide and water as the products. Now, in the equation we are provided the mass of carbon dioxide given off as 4.2 grams and the mass of water given off as 1.71 grams. Now here we really need to look at the mass of carbon. Remember, the question was a hydrocarbon, meaning a compound made of only carbon and hydrogen. We therefore endeavor to find the mass of carbon in the carbon dioxide given off, and carbon, based on the atomic masses provided in the equation, the mass of carbon is 12 divided by the molecular mass of carbon dioxide, which is 44, because we have it as carbon and oxygen. Carbon is 12, 2 oxygen atoms, that is 32, to give 44. So we have 12 divided by 44 times the mass of carbon dioxide given off, which is 4.2 grams. And this gives us 1.145 as the grams of carbon in the carbon dioxide. We also find the mass of hydrogen in water. The mass of hydrogen in water, of course, water is now provided as a molecule as such. From the equation, the mass of hydrogen is 1. One atom of hydrogen is 1. And therefore, if there are 2, it's multiplied by 2 and becomes 2 plus oxygen. The atomic mass provided in the equation is 16. So the mass of oxygen is 16. This gives the molecular mass of oxygen of water as 18. And the mass of hydrogen is 2 because of the 2 hydrogen atoms in the water molecule, divided by the relative molecular mass of water. This is multiplied by the mass of water that was given off as a product, and we get the answer here as 0.19. Now, finding out the masses of carbon and hydrogen only, and then getting the mole ratio, we now go the empirical formula way. The mass of carbon we obtained as 1.145 grams, and the mass of hydrogen as 0.19. So we get the moles in this. We get the moles by dividing by the atomic mass of each of the element, and that of carbon is 12. The atomic mass of hydrogen is 1. We now find the mole ratio, and here the mole for carbon is 0.095 divided, then the moles for hydrogen here is 0.19, because 0.19 divided by 1 is 0.19. We now divide by the smallest value between these two to obtain the mole ratio, and this is how we divide. And we later now obtain the mole ratio as 1 to 2, and therefore this gives the empirical formula of that hydrocarbon to be CH2.